I would be like, oh, I heard your takes dojo.
Remember when Tate pushed you in the headlock?
Oh, do I?
Well, I want to see the two of you go again. Like, for
That's
real.
when
You should
Tate was
come.
your sensei.
You should come.
He was my sensei.
You should come to the dojo.
Can you put him
And
in a
we'll
headlock?
have lots of fun.
We'll have lots of fun.
Yeah.
You should have seen Box on social. Tate Connor had a wrestling.
That was dumb.
Did Connor just sit on you?
No. I was.
No.
So we're doing wrestling rules, and wrestling rules is you have to get their shoulders on the ground, but like, I had Connor's stomach on the ground, so like I was just trying to like turn him over, but like, and it was impossible because Connor's Connor. But
That was Connor. Okay, take your calculator out. Go ahead and graph. We've graphed sine and cosine. The other graph that we're going to look at is tangent. You can look at other graphs like secant, cosecant, but we're not going to end up looking at those as of now. But the tangent graph, what we know is, or maybe you don't know or don't remember, but sine or cosine graphs look like this, right? So the sine and cosine graph, there is no domain restriction. You can plug in any angle measure and you're going to get out a value, okay? When you get to tangent though, since tangent is sine over cosine, right? There are spots where cosine is equal to 0. Therefore, you're not going to have the domain be everything because there's spots where you have cosine equal to 0 and you can't divide by 0, right? So there should be, when you go to graph the sine graph, you should see a graph that looks like this, and then a graph that looks like this, and a graph that looks like this. Is that what you see? Okay, now, some calculators have like a dotted line. Everyone, like some of them had it programmed in. I think it showed a dotted line going down there. Most do not. So does anybody have the dotted line, the vertical line that's showing it? Or maybe it's not even dotted, but a solid line. Anybody have a solid line? Okay. There is no solid line here. This would be, I put it dotted because it's what we call a vertical asymptote. An asymptote is a line that the graph doesn't, would go trend upwards at or downwards at, but isn't going to cross. Anybody know the value here that your graph cannot cross right there? And there's another spot over here that it cannot cross. Anybody know this value?
every half pi.
Yeah, every pi over 2. Now, why is it pi over 2? Because that's where cosine is equal to 0. So pi over 2, and then not every half pi, because pi over 2, pi works, because that would be right here at pi, but then every 3 pi over 2, so on and so forth. So our tangent graph, we haven't looked at it, that's why we're showing it right here. If you think about the domain of the tangent graph, the domain of the tangent graph is going to be not all reals, but it'll be everything except multiples of pi over 2. Except multiples of pi over 2. So Tate said every half pi, but it's not half pi plus half pi plus half pi. It's pi over 2 plus pi, so on and so forth. So you could say that something like this, it's all reals, but whatever, I guess, if we're using theta can't equal pi over 2, right? Or 3 pi over 2, or if you keep going, 5 pi over 2, right? So on and so forth. So, yeah?
Could we write like pi over 2 plus pi times x?
Yeah, pi times, usually they would say pi times n or pi times k, or k and n are integers. Yeah. Okay. So if we look at this graph though, okay, and then the range, I guess I want to talk about the range for a second. So the domain would be all reals to that. And then the range of this is your y values. What's my range of the tangent graph? How high, how low does it go? all reals there. Your range would be all reals. So your domain is maybe a better way to say, you know, is this, I guess. But if we eliminate, well, we'll just leave it like that for now. And that's negative pi over 2. Like this. Okay. So when we look at inverses, because that's what 7 6 is, and I think Ruger, you asked the other day, is like 1 over sine the same thing as inverse sine. And inverse sine is not the same thing as 1 over. If you recall our discussion of inverses, an inverse is where you are essentially switching your x and y's. Okay, so inverses are where you switch your x and y's and then you solve for y. If you remember doing that, I can't remember what chapter that was, a previous chapter, finding inverses. So we have 2 tests. One test tells us what if it's a function or not. Anybody remember what test that is? It tells us if it's a function. A visual test, vertical line test. So if we look at this, does it pass the vertical line test? Yeah. Okay, so this is a function. To tell if it has an inverse, does it pass the horizontal line test? No, because it would cross here and here and here, so on and so forth. So what we do when we talk about inverses for trigonometry is that we say, well, it doesn't work for all values to have an inverse. However, we could work, we'll notice that there's repetition in the graph, right? The graph is just repeating itself. So you could look at just a portion of the graph and you'll get a representation of everything that's going on. So I can actually take and say, okay, if I go like this, okay, and erase that, does it now pass, if I just look at that, does this pass the horizontal line test? Yeah, you bet. So what we do is when we take a look at inverses, okay, we then restrict what our domain is. So in this case, we would say, hey, we're only looking at this graph. Our domain is actually between, I guess we can say x or theta, it doesn't matter, but x is between negative pi over 2 and pi over 2. Our range is still all reals, okay? So our range is still all reals. So when we go to find the inverse just switches your x and y. So when we look at the inverse of tangent, okay, and if you remember inverse of tangent, if you remember the notation of inverses, tangent, what does your calculator have for the inverse? It's underneath your sine button, the cosine button, the tangent button. The notation is, right? You see that, -1. That is not an exponent of -1, it just represents the inverse. What the inverse is doing is just switching your x's and y's. So when we talk about the tangent inverse, now let me state this, is that tangent inverse of theta, that's how we would write the notation. The reason we write notation like that is, this is a side note, and you'll see this later in chapter 8. For sine, let's say you have sine theta. If you write sine theta squared, that is different than sine theta squared. Okay, so if you're looking at sine theta, if we were squaring it, the issue that these two are not the same. Okay, because here your angle is getting squared. Here the ratio, the whole ratio is getting squared. So when we do notation, if we want this notation, meaning we want the whole thing being squared, what they actually do is they say, hey, we're going to write it this way, sine squared theta. They put the exponent on the sine part and not on the angle part. And it eliminates having to write parentheses and an exponent on the outside. It's just a simpler notation. So like inverse, they just put it, you wouldn't put it here, because then what you're stating is that this is actually the theta to a -1 exponent. And so that's why you see these, and although -1 is representing inverse, not representing exponent, but I just thought I'd throw that in there now, is that when you see exponents for the whole thing, you'll see them put right there on the trig function there. Okay, so back to tangent inverse. If it just switches your x and y, your domain then, if it just switches your x and y, your domain of the inverse becomes all reals, the range becomes negative pi over 2, and this is your y values now, and then negative pi over 2 up to pi over 2. So it just switches your x's and y's, and what your graph would look like then is that your domain is all reals, but your range is this, so your range is going to have this flipped, pi over 2 down to negative pi over 2, like this, that your graph can't go between, and then you're going to have the graph is going to look like this. Okay. Now, I'm not going to do a bunch of work of graph the inverse function and make you understand all of this, but it's just to help us understand a little bit that inverses have to pass the horizontal line test, and then in order to do that, you erase part of your graph and only look at a portion of the graph. And so then it flips your domain and range, and your graph would look like this. Now with sine and cosine, the same concept occurs, because if the issue is in sine and cosine, right, if we looked at this graph, does this pass the horizontal line test for the sine graph? No, doesn't. So then we say, but there's repetition over and over and over. It's the same thing occurring. You look at the unit circle, right? All your ratios are the same. The same repetition happening. So what we can do is we erase the sine graph so that it does pass the horizontal line test like this. And then we say, we're just going to look at this portion of the sine graph, and that's going to be enough to represent everything. Okay? Again, you're not going to have to understand all the ins and outs of this. Most of the basic stuff we end up doing is we're just going to look at how we use our calculator and some basic concepts of taking inverses to find information. Okay, so it changes, then we say, okay, the domain isn't all reals, the domain is just from negative pi over 2 up to pi over 2, and then, the range and stuff like that changes as you do the inverse. Okay, so let's do a couple brief examples so we understand a little bit that to keep with the horizontal line test, we shorten the graph. We only look at a portion of the graph, but it's enough to represent all the ratios that we need. And so you have your calculator out, and they're going to say, use a calculator or a table to find the nearest tenth of a degree. And they're just going to ask you a basic question like this. They're going to say the tan inverse of 3/8, or whatever they have, 7/3. Let's go tangent inverse of 7/3. So the question here, though, is what mode should you be in? They will tell you, because then I'll show you what we're doing here is, they are going to say this is theta should be degree mode. Okay, so make sure you're in degree mode and you tangent inverse of 7/3, you're in degree mode because they tell you what mode to be in. And so you do the inverse tangent button on your calculator, you hit 7/3, and what do you get back out?
66.8.
66.8, okay? So 66.8 degrees. So what this is stating for you going backwards is this. What you're actually looking at is you're saying the tangent of 66.8 degrees is equal to what ratio? The ratio was 7/3. So that's what you were doing. You're just going backwards and saying, I know the ratio, what angle measure makes the ratio, and I'm saying what angle measure is my y value over my x value is 7/3. Tate.
Isn't tan to -1 just cotangent, right?
Nope. That's the reciprocal, which is not the same as the inverse. That's what Ruger was asking the other day. Tan to the -1 is not the same as the reciprocal, because tan to the -1 is not a exponent of -1 where it flips it to the bottom. It's just representing the inverse. It's an inverse notation. So if I said, hey, what's x to the -1? That's stating what is 1 over x. Right? When I say f, that's not f to the -1 of x, it's f inverse of x. So it's an inverse function. So these two things right here represent two different things. You have to know where it's being placed and how to use it. So it's not 1 over. This does not represent 1 over. This does represent 1 over.
Yeah, I don't know what the inverse means then, so what does inverse do then?
Inverse is just where you switch your x's and your y's. That's all. An inverse is essentially just switching x and y. For our purposes, of trigonometry, what it allows me to do is, and I'm going to set this up here, but let's do another example here. I'm sure we'll call that 1, we'll call this 2. If you have a function like this, we say, okay, sine theta is equal to, and we'll stick with degree mode, 1/2. We actually know what the answer to that is, or you should know the answer to that.
Inverse sine of 1/2.
So inverse sine of 1/2. So if you want to know what the angle measure is that forms a ratio of 1/2, where your ratio is your opposite over your hypotenuse, or your y value over your r value, the inverse allows me to, or allows you to find out what angle measure gives you that ratio. So it's going in reverse, if you will. So that's really cool. So now we say, hey, I know I got this ratio of 1/2. What's the angle measure that gives me that ratio? Now you have to know which ratio you're talking about. Meaning, is it your y over your r? Is it your y over your x? Is it your x over your r? And since I'm saying sine, we know it's y over r, or opposite over hypotenuse. So you all should know what theta is.
30 degrees.
30 degrees, right? Now, do this. Cosine of theta is equal to 1.52. And this is in degree mode.
So you just do negative cosine 5.2.
Use the correct terminology. Inverse
Okay.
cosine.
No, we gotta switch
Inverse
to
cosine
different mode.
1.5.
No,
It
we're
says error.
Degree mode.
We're still in degree mode?
Should be in degree mode.
Why does it say error domain?
Right. And even if you change the radian mode, it'll still say the same thing.
The value is 9 to command.
Maybe let's try this one. Maybe make our. You're gonna get the same error, but just to like make it easier to discuss, maybe it's easier to discuss.
Alright.
Domain error, right? Why is there a domain error?
Although cosine can't be over 1.
Why not? I agree.
Alright.
I don't know.
The ratio, right? The ratio is x over r, right? So where's your x value greater than your radius in a circle?
Never.
So if you have a circle here, where is the x value greater than the radius?
Oh, no.
Never, because yeah, you'd like, well, if I wanted 2, I'd have to have a radius here and an x value of 2 that falls outside the circle. It's not on the circle, right? So any value that we're dealing with has to be on the circle. So you'd have to have 2 over 1 to get that, and that's not on the circle. So that's outside of our domain, can't work, does not work for us. Okay. Now tangent, that's possible, right? Because tangent's comparing where is your y value over your x value. So y can be greater.
Even with your sine, you can do it too.
No, because sine is stating, yeah, Riley.
So,
Yeah, you bet. Sine is stating where's your y value over your r value. So here to here, this doesn't fly. If you said, oh, the sine of theta is equal to 2, the same issue applies because you're stating my y value is 2, my r value is 1. There is no spot on the circle where that works.
yeah.
So, and then if they say radian mode instead of degree mode, it's the same thing, right? You just do the inverse of the ratio, but it's in radians, and so you get a radian answer. Just don't put don't put 30 degrees. Just put the radian value from your calculator. Now, if you say, let's say radian mode, we'll call this number 4. Now I'm going to say radian mode, and I'm going to say sine. Well, they might just have you do this. Sine inverse root 3 over 2. Okay, so go ahead, do inverse sine of root 3 over 2. And it's in radian mode, right? So radian mode. 1.047, okay? And the thing about this is, I'm going to say now exact value. 1.047 is not an exact value. Or exact value slash terms of pi. Why am I saying exact value slash terms of pi?
He uses the radian, or the unit circle.
Yeah, because root 3 over 2 is a
30, 60, 90. Even 60 degrees.
I'm saying what? Root 3 over 2 is a unit circle value, right? So where is root 3 over 2 and relationship to sine? So what you're really asking is, remember, this is asking where is sine theta equal to root 3 over 2, not in degree mode, but in radian mode.
Mm-hmm.
And in terms of pi, it would be pi over, or something, maybe more than just pi.
Pi over 3.
Pi over 3?
Well,
Yeah.
why 3?
Because it's 60 degrees.
1 pi over 6, 2 pi over 6, which is pi over 3.
How do you know 60 degrees? It came out with like 1.0471.
Right, we're asking for the angle measured in terms of pi. So we know that root 3 over 2 is a unit circle value, right? So when you see unit circle values, you should be able to put them in terms of radians. I'm sorry, in terms of degrees. I'm sorry, in terms of pi.
Okay.
Now, if this was degree mode, wouldn't that be really easy? Yeah, because your calculator is going to give you 60 degrees. It's in pi mode, if you will. When it's in radian mode, then it becomes a little bit more challenging. So again, if you saw cosine inverse of root 7 over 9, is that a unit circle value? You don't need to do this on your calculator. Is that, no. So can it be in terms of pi? No, not unit circle pi. You could convert it in terms of some sort of pi and get a term of pi, but it's not going to be a unit circle pi. So that one, no problem. What are the values here that you're like, ooh, that's an exact value, that's an exact value? What are they going to be? Root 3 over 2, 1/2, root 2 over 2, 1, 0, -1, and then any plus or minus, plus or minus, plus or minus. So all those values, when you do cosine inverse of this in terms of radian mode, all these would tell you, ooh, something's going on, unit circle stuff. This, not a unit circle value. You still can do it, it's just not a unit circle value, not going to need to be in terms of pi. Now, tangent adds another complexity, and that's what you'll end up having to think through too at some point here is tangent adds another complexity where the unit circle values, you don't see them up there, right, for tangent, but you'll start working with memorizing these where you'll have root 3 over 3, you'll have root 3, and you'll have 1, and -1 and 0. So you'll end up, which doesn't add that much more complexity, it just adds a few more numbers. But again, root 3 is a real distinguisher of unit circle stuff. So if I said, let's try this one, hey, no calculators, and I want it in terms of pi, so you don't need to worry about degree mode or radian mode on your calculator because I want it in terms of pi, which tells you Excuse me. This tells you, hey, unit circle value does root 2 over 2. I want it in terms of pi. So no calculator needed. Where is that going to be?
Something to do with 3 pi over 2.
Pi over 4.
Okay, we're making headway. Pi over 4, but not quite. Why is it not quite?
Because it needs to be in a
5,
different
5.
section of the unit circle for it to, a different quadrant for it to be negative.
Okay,
5, 4, 5.
5 pi over 4.
Or yeah, 5 over 4. Oh no, no, that's wrong. That's the wrong quadrant. It's gonna be that quadrant. So
okay.
What?
You guys are on the right track. Is what
3
you're
pi over
asking.
2.
No.
You're asking this, right? What angle measure gives you this? So sine is which quadrant? I'm sorry, sine is, where is sine negative? Which quadrant?
3 and 4.
3 and 4. So here
5
and
fourths.
here. So you're saying 5 fourths pi, 5
There you
pi
go,
over
5
4.
pi over 4.
Okay, so you're saying the answer should be 5 pi over 4, right?
Yeah.
So if you go, and you said sine of 5 pi over 4, it should equal negative root 2 over 2. Now, your calculator won't give you that, right? You're not going to hit sine of 5 pi over 4 and it gives you out root 2 over 2. It'll give you a decimal value. What is root 2 over 2? Just so as we're working the calculator, we're getting decimal values out. What is root 2 over 2?
Like the 45 degree.
I know, but the ratio, what is that on your calculator, sir?
2 over 2, 0.771.
0.707?
Yeah.
1 or something? Okay. So now, so we know that like if you get 0.7071, so if you hit sine of 5 pi over 4, are you getting negative 0.7071? You're in radian mode. So radian mode, hit sine of 5 pi over 4, are you getting out negative 0.7071 on your calculator in radian mode? Is that what you're getting? Are we confirming that? Okay, good. Now, I want you to, so also, what is 5 pi over 4 in decimal form? So go ahead on your calculator, go 5 times pi over 4. What is 5 pi over 4 in decimal form? 3.926, okay? So and you're in radian mode, right? So go ahead in radian mode, hit this on your calculator. Now I'm like, hey, use your calculator, what's sine inverse of negative pi over 2? We're expecting the answer to be 5 pi over 4 or 3.926, because that's what you guys just told me.
Negative 0.785.
Negative 0.785,
Yeah.
okay? But we were expecting this, but our calculator gave us this, okay? So negative 0.785, that's a ratio with pi. Let's try this ratio. What's pi over 4? You have pi divided by 4. What is that on your calculator in terms of a decimal?
0.785.
0.785. So what this is stating, what's negative 0.785 stating then in terms of pi, it's stating this is the same thing as what? Negative pi over 4. So the answer is actually not 5 pi over 4, the answer is negative pi over 4.
So the inverse, this is like switching quadrants diagonally?
Well, what's happening is, if you recall at the beginning, I said, hey, sine goes like this, right? Does not have inverses for the whole thing. And so what they do is they say inverses, we have to shorten our sine graph so that it actually only goes between negative pi over 2 and pi over 2. So any inverse signs are going to give you values between negative pi over 2 and pi over 2. What two quadrants is that dealing with? Negative pi over 2 to pi over 2. First and fourth. This will give you positive ratios, this will give you negative ratios. So sine of negative root 2 over 2, you were accurate in saying that is the ratio out there at 5 pi over 4, but we don't include that when we are looking at the inverse, so therefore we are looking at this ratio, but we can't look at it as going from here all the way around, because then it would entail all of this, which does not pass the horizontal line test for us. Therefore, you're only looking from here to here, and to get down to here, you have to go in a negative direction, so negative pi over 4. So that's a little bit of a tricky thing to look at, is understanding you're only working with that negative pi over 2 up to a positive pi over 2. Nicholas?
Wait, so why when I plugged it in, I got two different answers?
Here?
Yeah, like I plugged in root 2 over negative root 2 over 2, inverse sign of that, and I get negative 0.6496. Or no, that's, no, I get, I didn't do the inverse sign.
That might be why. I don't know. You'd have to show me if you're getting two different answers. We'd have to.
Yeah, so I did inverse sign of pi over 4, and I got 0.9033.
Well, inverse sine of pi over 4 is a different. That's completely different than pi root 2 over 2.
Oh, so I need to do it normal. Oh, yeah.
Those are two different ratios.
Okay, so I did sine of pi over 4, and it gave me 0.707.
Yeah, sine of pi over 4 would give you a positive,
Yeah,
because that's pi over 4 there.
yeah. And so, like if I was just doing it in negative, change it, so that, and then if I do inverse sine of root 2, negative root 2 over 2, I get 0.785.
If you do inverse sine of what? You're only getting out one answer. If you do this right here, you're only on your calculator, you're in radian mode, you're only going to get out this. You're mixing and matching, I believe, like you're changing your angle measures and changing your quadrants with whatever you might be doing. It just punches into your calculator and you're going to get this value.
It says
So you're not getting out two values. You're just getting out this.
Yeah.
So with whatever you're processing, which is fine, you're processing, you're doing the wrong angle measure. It's not the exact same ratio. And this isn't an angle measure, this is what you're trying to find out, what angle measure gives me this ratio.
Okay, I see. I was just wondering, like, so I get, so like you get 0.784.
Mhm.
So shouldn't we just be allowed to like plug that back in, and then shouldn't it give you root 2 over 2?
If you plug in, you're stating, yeah, if you say what is the sine of negative 0.785,
Yeah, shouldn't that give you negative root 2 over 2?
well, this is rounded, so it won't give you.
I know, but if I just do pi over 4 instead of
I have a question.
So if you plug in sine of negative pi over 4,
yeah, shouldn't that give me?
what do you get when you plug in sine of negative 0.785?
You put a subtraction sign instead of negative.
Thank you.
So you put this in
7.068.
This makes it set.
What here?
Incomplete,
7.068.
invalid argument.
7 point,
Thank you.
7 point,
Or 0.706.
0.7068.
Yeah.
Okay, and then what do you get when you do this?
0.707.
0.707. So
But shouldn't it give you like the value of root 2 over 2? Never mind,
I think this is the value of root 2 over 2. If you go root 2 over 2 on your calculator, what is, I don't think I put that decimal, what's root 2 divided by 2 on the calculator to do? I did do it somewhere over here. It's not root two.
Yeah, I see. I got it, yeah, I got it.
It gives you the value of 0.707. Are you tracking with it?
No.
No? Okay, there you go.
That's why we're recording.
Okay, so that's where it gets a little bit tricky, is that you have to pay attention to when we get into unit circle values like that. You can't just hit enter on your calculator. You have to think through. Now you can confirm it with your calculator, right? Do inverse sine, and it gives you the negative 0.785. It tells you what direction you need to be. It tells you quadrant 4, and then you can work it out from there what the pi is. So, okay? Great, we will review Monday.
He's robbing me.